Hello and welcome back. Today's video will be third part of our mini-series of designing and building interesting electronic circuits using infrared diodes and receivers. Using what we have learned in previous two videos, episodes 19 and 20, we will design and implement a simple circuit to test buttons on TV remote. So, let's get started. If you enjoy practical electronics tutorials like this one, please subscribe to the channel. Don't forget to like the video and enable notifications so you don't miss future projects. Thank you. Before we continue, we strongly encourage you to view episodes 17 through 20 of this season, as they are prerequisites to fully understanding principles and math behind the circuit we are going to implement and test today. You will find links to these videos in the description box. We will use a portion of the circuit, namely receiver and detection part, that we have designed and tested in those videos. On screen you have a full schematic we have used. Since we do not need an infrared source, we will discard this portion of the schematics, as TV remote, or for that purpose any infrared-based remote, will be the source of infrared light. So, our final schematics will look like this. The choice of components and power source have been explained in every possible detail in previous two videos. This is the part of the circuit we are choosing to keep for this scenario. We will quickly go over main sections and explain function of each one. We have 5 volts DC power source provided to breadboard rails. Red line represents positive, and black line ground rail, respectively. In order to filter out any noise that power source can introduce into the circuit, we have short-circuited positive and ground rail with 0.1 microfarad ceramic capacitor, marked 104. Please, make sure you use ceramic, non-polarized type of capacitor. This capacitor is not in any way absolutely necessary, but it helps get a cleaner signal on the oscilloscope, especially if you are using any type of AC to DC converting power source. Next, we have our infrared receiver. This part of the circuit is implemented by using QSD123 phototransistor, with 10 kiloohms resistor in series. Together, they form receiver part of the circuit. We have provided schematics that this part of the circuit represents. Choice of 10 kiloohms resistor is based on current generation, necessary to properly bias NPN transistor in detection part of the circuit. And last, we have a detection part of the circuit. This part of the circuit is implemented by using NPN2N3904 transistor, white LED indicator, and 150 ohms collector current limiting resistor. We have provided schematics that this part of the circuit represents. The function of this part of the circuit is to control indicator LED and to switch it on or off, depending whether button pressed on remote emits infrared light or not. If remote emits light, the phototransistor will generate enough base current for NPN transistor to go in saturation mode, and indicator LED will light on. This means that tested button on remote works. You can repeat the same process for all buttons you wish to test. So, let's see how this circuit functions in real life. We will power on the circuit and point remote control toward infrared phototransistor and push button we wish to test. If button works, remote will generate infrared beam that will activate phototransistor. Then, the phototransistor will generate enough current to properly bias the NPN transistor into saturation mode of work, and white indicator LED will light on. We repeat the same process for each button we wish to test on our remote. This circuit can be used to test all infrared-based remote controls, not just ones for TVs. This was a lot of fun. We have learned how to design, build, and implement infrared receiver circuit. Now, we can take this basic design, and adjust it to serve our design needs for more specific application of infrared receiver or infrared detection circuit. Also, we have a short video on our channel, demonstrating how you can test infrared remote using smartphone camera app. So, please go and check it out. Please, Before you leave, show your appreciation by liking this video, leaving a comment, sharing it, and please subscribe to the channel. Thank you, and see you next time. Bye.